As we look at matrix multiplication, it's a little different than our operations of addition and subtraction, because here it doesn't matter if the matrices are exactly the same size. It will be, in order to successfully multiply matrices, the number of columns in the first matrix must match the number of rows in the second matrix. So remember, we label a matrix by the rows and then the columns. So as we look at matrix C, this would be 1 row by 3 columns, 3 rows by 2 columns. So since the rows of 3 in our first matrix matches the columns of our second 3 in the second matrix, since those match, the resulting size of the matrix will be a 1 by 2. So let's check this next one. A 4 by 5 times a 5 by 2. The middle numbers match our columns and our rows, such that we're left with a 4 by 2. Here, the 4 does not match that 2, so this one is impossible, or you could also say it's undefined. I would always start off and make sure you know the size of the matrix that you are creating. So as we look at this one, this is a 2 by 3 matrix times, so 2 rows, 3 columns, a 3 by 2 matrix. The middle numbers match. What we're left with is a 2 by 2 matrix. So our new matrix will be a 2 by 2. And what I do is I start off and I'm like, okay, well, this is going to be a 2 by 2. So I kind of draw that 2 by 2 to remind me what size it should look like in the end. Now here is the fun part. If we're looking at completing what element will go in this first row, first column, that spot right there in our new matrix, we are going to take the first row of our first matrix and the column of the second, and we're going to multiply them together. So we're going to do 4 times 4 is 16. We're going to do 3 times negative 2 is a negative 6. And we're going to do negative 1 times 5 is negative 5. We'll talk about what we do with that next later in a minute, but I'm just going to go through it for each of the elements of our new matrix. So now let's look here. We're still in our first row, so we'll still use that first row, but now we're in the second column. So we'll take the second column of the next matrix. Same thing. 4 times 3 is 12. 3 times 2 is 6, so we're going to add 6. Negative 1 times 3 is positive 3. Okay, 2 more. Let's look at the next one. So this one right here. Now we're in the second row, but we're in the first column. We're going to multiply these two together. 6 times 4 is 24. Negative 2 times 2 is positive 4. 1 times 5 is 5. One more. This last one is once again the second row, but now it's the second column. 6 times 3 is 18. Negative 2 times 2 is negative 4. 1 times 3 is negative 3. We did the basics of we did most of the hard work, I guess you could say now. The last thing you can do is you can just simplify that 2 by 2 matrix. So when I do 16 minus 6 minus 5, I end up with positive 5. 12 plus 6 plus 3 gives me 21. 24 plus 4 plus 5 is 33. And finally, 18 minus 4 minus 3 should give you 11. Okay, so let's try it with the next one. As we look at B, this one is a 1 by 3 times a 3 by 2. So the middle two numbers match. We're left with a 1 by 2 matrix. So this one will be long, but it will have 2 columns, so something like that. Same idea applies here that we did in the first one. First row, first column. First row, first column. Multiply it together. 6 times negative 1 is negative 6. Negative 3 times 5 is negative 15. 2 times negative 6 is negative 12. I'm going to simplify it this time right now. If I add all these together, I end up with negative 33. Okay, the other element in our matrix, first row still, second column. Multiply those together. 6 times 3 is 42. Negative 3 times 3 is negative 9. 2 times 1 is 2. Add that together, you get 35. So our new matrix is the 1 by 2 matrix, 33, 35.